Hello everyone. This is James Shore with another test-driven JavaScript video. I'm recording this on December 30th, 2012, right at the end of the year, and this is going up tomorrow, so Happy New Year, everybody. So at the end of last episode, we were working on getting the code for our WeWikiPaint application tested. We wanted the ability to test what we have right here, which is as we click, lines are drawn in our WeWikiPaint application. And I love the fact that this code is working because this is stuff that's actually the kind of thing that most people would say you just don't test. So we are actually testing it and the test is failing. But those are minor details. The problem here is that in our test, we're telling it to click the mouse at various locations within the paper. And then we're expecting that we see line from here to here, 20, 30, 50, 60. And then we see a line from here to here, 50, 60, 40, 20. And it's not actually doing that. Instead, it's seeing 20, 30, 50, 60 to 50, 60, 40, 20. In other words, it's seeing the line as being backwards. And this is what we covered last time. And the reason is because we're getting the positions of the lines by looking at the bounding box, which is going to be a box around the line that goes from the upper left to the lower right. So when we have a line that goes to the left, it is going to say that it's backwards. So the question I left you all with at the end of last episode was, how do we solve that? Do we modify our test so it just is in the order of what we're getting back? Do we write a new assertion that is more sophisticated and normalizes our expectation? Or do we do a more complicated way of getting the information out of Raphael, our SVG tool, to determine, to get the actual path rather than the bounding box? And that would be a lot more code. And I close by asking you all to share your suggestions in the comments. And I should have known better because it was Christmas and nobody's watching these videos on Christmas. They're spending time with their family. So I didn't get any comments whatsoever. So I'm just going to do what I think is the right thing to do here. And what I think is the right thing to do here is to look at look at the actual paths being generated by Raphael. And the reason for that is, although this get bounding box trick is easier, these are the kinds of things, these little niggling problems are the kinds of things when you use a trick that's not quite sufficient. For example, if we start drawing paths with more than one line segment, the get bounding box approach won't work. When we start drawing paths that aren't line segments, that they're curves or ellipses or something like that, the get bounding box approach won't work. So I think we're going to get rid of the bounding box approach and actually look at the real paths being written into the paper. It will take a little bit more work and it will take a lot more code, but that code is something that we can reuse in the future. And it is less likely to give us these sorts of annoying, weird problems that have consumed so much time. So we've already got that working in IE8. We proved that, yes, the correct paths are being written out to the paper at the end of the last episode. And we did that by looking at the actual path for IE8. Now I want to continue on and get it working for the rest of the browsers. The reason it works for IE8 is because IE8 uses VML. And now we need to get it to work in IE9, which uses SVG, but it has a different format than Firefox, Safari, and Chrome do. So let's go ahead and just get this working. Rather than returning all of that, we actually want to return this. So let's say IE9 1, IE9 2, IE9 3. These values, by the way, are coming out of our regex, which you can see up here, and the subscripts correspond to the groups that we're matching in our regex. So this approach is a bit fragile in that if we don't match line segments, it will fail. But that is something that I think will be fairly easy for us to expand in the future. So now that I've got it returning this, I think I think it will start working on IE9. And there it is. It does work on IE9. Okay, so now we need to do the exact same thing for Firefox using a different regex. And then I'm going to want to come through here and clean up this code because it's gotten a bit ugly. Okay, so the format it uses, oops, somehow I lost my comment. Okay. The format it uses is M with some digits, followed by a comma with some digits, followed by L, like that. Okay, and if I've done that right, it should clean up the rest of our tests. Yes, yes, it does. Okay, and now our tests are finally working. So let's take that out. Let's take out that dump we've got somewhere. Where is that happening? Here, I think. Okay, so let's go ahead and check this in. Okay. Now our tests work on all browsers, even when paths go right to left, which was the problem. Okay, now let's go ahead and clean this up. We need to, so we've got this click mouse function, and that is doing a pretty good thing. We've got this drawing elements, which gets the elements out of the paper. We've got path for, which gives us the path for a drawing element. And then we've got SVG and VML. And all of these are basically doing the same thing, which is parsing out 4 items from the regex. So let's go ahead and factor that out. Let's try this. Yeah, let's try saying path regex equals that. In that case, I think we want that comment. Otherwise, we want this case. And then in both cases, we'll do that. Okay. Now, oh, and here, of course, we want that to say path regex. So that still works. Good. Okay, let's rename this to be path components. And that's good enough for now. I think I could factor this out as well, but it's a bit more complicated because I've got to divide by this VML magic number and so forth. So I think I'll leave it as it is, and if I am back in here and feel like it needs improving, then I can always do that later. Okay, so let's go ahead and pull this down to here. and take a look. So we click mouse and then expect paper paths to equal what they equal. Okay. And that should all still work. Great. Let's check that in. Just cleaned up path parsing a bit. Okay, so now we've got our code drawing line segments in response to clicks. That's great. Now, let's get it. Let's get it drawing line segments in response to drags. Now, this is a bit trickier. So I guess what we need to do here is rather than saying to click the mouse, we need to say click and drag mouse. Like this. Or rather, yeah, click and drag mouse from 2030 to 5060. Okay. And how are we going to do that? I guess what we're going to do is with a mouse down and mouse up event. So let's see if we can change this to be mouse down. Guess what we'll need is we'll need a mouse down, a mouse move, and then a mouse up event. So let's see if we can do that. I'm going to leave this as is for now. And I guess this will be, it says click now, but I guess what we want is for it to be mouse down. Let's go ahead and look at the jQuery documentation. Okay, I'm back. It looks like mouse down is what we want. So let's try saying mouse down. Oops, wrong spot. Let's try saying mouse down here. And then we also need a mouse up event. I'm going to start out by not doing click and drag, but instead saying mouse down 2030, mouse move 5060, and then mouse up 5060. Yeah, I think so. I had a note that we were going to test one click, then one path, then multiple paths. But actually, I think it will be easier to do the drag first and then do that. So mouse down, mouse move, and mouse up. Pretty straightforward. I'm going to just cut and paste this to do down, mouse move, and up. And then what we need to do is factor out duplication in mouse move, mouse event code. But I think for now, I should be able to just say mouse down, mouse move, and mouse up. That's a bit of a guess because I haven't looked up what the actual events are or how they should work, but I'm hopeful that it will work. Okay, so we've got our mouse down, mouse move, mouse up. And up here we're calling mouse move, mouse down, mouse move, and mouse up. Let's see what happens when we run this. It shouldn't work because I haven't written the code to make it work yet, but I want to make sure it just doesn't crash. Oh, interesting. It says it works. That was unexpected. Oh, well, it's worked because I don't have an assertion anymore. If I put this in here, yeah, now it's failing. Okay, so that's the end of this episode. We'll pick up next time by getting this mouse dragging code working. So what we've done is we're working on our WeWiki Paint. We're trying to get it so that we can drag around instead of clicking. And We've just finished making the assertions easier to write and read. Now we are get basic drag and drop. Well, not so much drag and drop, just basic drag to work. So that's what we'll pick up with next time. Thanks for watching, everybody. I will catch you next time.